Hello students, in this video we will study the basics of sections of solids. We will be studying the concept with the help of a question which will describe how to draw the sectional top view, front view and the apparent view of the section. Let us read out the question. A square pyramid of base edge 30 mm and height 60 mm rests on its base on HP such that all its base edges are equally inclined to VP. A cutting plane inclined at 45 degree to HP bisects the axis of the pyramid. Draw its sectional top view, front view and apparent view of the section. So let us discuss the concept.
So we'll understand this with the help of an example. Okay, so this is a question. This is a single question. One question it is. So in this first part, you can see it is given a square pyramid. First of all, it is a square pyramid, right? Base 30 mm, height 60 mm. This is also given to you. So it means it is a square pyramid whose size is 30, base edge is 30 and height is 60 mm. It is resting on HP on its base such that all the base edges are equally inclined to VP. So this much of the question, it comes under projections of solids. Okay, so this you will have to draw. The next is a cutting plane inclined at 45 degree to HP bisects the axis of the pyramid. Okay, so there is a cutting plane, okay, which is cutting this pyramid at 45 degree inclined and it bisects the axis. Okay, so this is the question and you have to find out sectional top view, front view and apparent view of section. Let us say this is the square pyramid. Okay, this is a square pyramid, right? Okay, so it is resting on HP such that all of its base edges make equal angle with VP. It is resting on HP like this. Okay, but all the base edges, now here you can see the base edge, this base edge and this base edge are perpendicular to VP. This base edge and this base edges are parallel to VP. But if I do it like this, if I rotate it like this, so here you can see all the edges, base edges are making an angle of 45 degree with VP. Even if I just see, this and this. Okay, so let us start it. First of all, we will draw the projection of solid. So it is like this. This is the top view. Let us, this is A, this is B, C, D, and let it be O. So what it is, if you see this object from the top, it will be placed like this. It is placed like this. So if you see it from the top, just see. Right? This thing will be visible to you. So this is the top view. right? Then after this, you draw the XY line. This is X, this is Y. So draw the projection lines now. Height is 60 mm. Let us say this is 60 mm. So when you see it from the front, this will be A dash, this will be B dash, D dash, this will be C dash, and this is O dash. This is just the projections of solids. Now let us read the next part of the question. It says a cutting plane inclined at 45 degree So cutting plane inclined at 45 degree to HP bisects the axis of the pyramid. So there is a cutting plane. There is a cutting plane. Let us say this is the cutting plane. It is cutting it at the center. Bisecting means if this is 60, from the center at 30, it is bisecting means it is dividing it into two parts, right? So let us say this is 30 mm. Right. So from here you can draw the cutting plane line. So it is inclined at 45 degree. It is like this. Right. So this angle is 45 degree. And it is thick from the edges, cutting plane line. Right. Now let us just see this. So your object is placed like this, okay? Just understand the idea. Your object is placed like this, okay? Now this cutting plane, it is cutting the object from here, inclined at 45 degree. Okay. So after that, if you just see it will be intersecting the slant edges, like this slant edge, this slant edge, this slant edge, and this rear one. It will be intersecting the slant edges. Okay. So wherever it is intersecting the slant edges, we will name those points. Just see how we will be naming them. Now, wherever it is intersecting OA, okay, it is intersecting OA here. So let us say this is 1 dash, means corresponding to A, you name it 1. Then OB. Wherever it is intersecting OB, it will be 2 dash. Then O3, OC, it will be 3 dash. And OD, it will be 4 dash. So just see wherever this cutting plane will intersect the slant edges, okay, there you will name them accordingly. Like OA will be, if wherever it is intersecting OA, it will be 1 dash, okay, in the front view. Means, or you can say OA will be 1, wherever it is intersecting OB, it will be 2, OC, it will be 3, and OD, it will be 4. Right? Then from here, wherever these are intersecting the, you can say, the slant edges in the front view, from there you will draw projection lines. Like this is O dash A dash in the front view. This is OA in the top view. So this is the front view. Okay, this is the front view. So this is OA, OB, OC, and OD. Similarly, when you see it from the top, so this is OA, this is OA, OB, OC, and OD. Okay. Now, wherever it is intersecting the slant edges, or you can say wherever 1, 2, 3, 4 are there, from there you will drop vertical projections on these lines. Like whatever is there on O dash A dash, from there you will drop a projection on OA. Similarly, so let us drop the projection line. So it will intersect over here. So this will be 1 because it is the top view. Then 2, from 2, if you draw the projection line, it will not intersect anywhere. It will be, since it is a collinear line, so it will not intersect it. So, okay, so from 2 and 4, you will not be able to intersect. Let us draw it from 3. Sorry, I had to draw it with green color. Just see. So this is this is 3. Okay. Now, if you see you are unable to identify where 2 and 4 are there in the top view, because 2 will be over here, 4 will be over here. And if you see, like this distance is, like this. Now let us say if this is the center, let us say this is the center. So this distance will be small and this distance will be large. Vertically, horizontally, if you see, this distance means this distance is small, this distance is large. This distance is small, this distance is large. This is what I mean to say. Right? But if you see the other way, if you see it like this, distance from this center to, this distance and this distance, or if I show you the top view, if you see the top view, so from the center, let us say this is the center. So from the center, this distance, and from center, this distance, these will be equal, isn't it? Again, I am repeating, let us say this is the center. So this distance will be less. This distance is large. No, these two are unequal distances, but this distance from the center and this distance from the center, it will be equal. For this, what we need to do, just understand it carefully. For this, like we cannot find this by any other method. So what we will be doing, so can you see this? So draw a horizontal line. From here, so you just draw a horizontal line, and from here you draw a vertical projection line on OC, like this. Now, wherever it is intersecting this OC, let us name this as M dash, and let us name it as M. This was 3. So now from here, what you need to do, you keep your compass here open till this point and mark an arc over here and mark an arc over here like this. So from here, you will get 2 points. So this will be on OB, it will be 2. Let it be 2 and let it be 4. So join 1, 2, 3, 4. Okay, join 1, 2, 3, 4, and you can erase whatever is there in between like this. Right? Now what is this? So this is what, when you are viewing it from the top like this. Okay, so basically this is the cut portion that will be visible to you from the top. So sectioning has been done over here, right? So this is known as apparent view of section. Why it is known as apparent view of section? Just see why it is apparent shape, because this is the cutting plane. It has been cut like this. Okay, let us say this is my hand is the cutting plane, and you are viewing it from the top like this. So it is inclined, isn't it? When you see it from the top, how come you will be able to see the actual shape? It will be the apparent shape only. In actual it is this much, but when you see it from the top, it will be visible like this much only. So that is why it is known as apparent shape. So how will we be drawing the true shape? How to obtain the true shape? So if this is the cutting plane, so if we want to get the true shape, I will have to see perpendicular to this. Okay, I'll have to draw a view which is perpendicular to the cutting plane. Like this, I will have to draw. So then I'll be getting the actual shape, right? So what you need to do, First of all, you draw a line parallel to this line over here, wherever the figure ends. Let us draw it. Is it parallel? Tell me now, is it parallel? I think yes, it is parallel now. Just draw a line like this. So let it be x1 and let it be y1. Okay, then from there, what you need to do, again, I am repeating, I am viewing this object perpendicular to this cutting plane. Now I am doing it like this. So now what you need to do from these 3 points, you draw perpendicular lines, extend perpendiculars. Let us draw perpendicular lines. Now, these should be correct. That is why I am using this. Similarly, from this 2 and 4 also, draw a line parallel to this line that we have drawn. Then from 3 also you have to do. Yes, please. Now just see what we will be doing after this. Now one is this reference line, other is this reference line x1 y1. One is xy, other is x1 y1, right? Now what you need to do is you need to draw this 1, 2, 3, and 4 over here on these lines. This is the main idea, main concept, basic concept behind this. So you have to draw this 1, 2, 3, and 4 over here above this. Okay. So how you will be drawing, just understand it carefully. Just see, this is the xy line. So from this xy line, you measure what is the distance till 1. I am just drawing it with red color. Measure this distance, how much it is. Okay, measure this distance. Yes, no, okay. So measure it and mark an arc over here. Let us say it comes out to be here. So I am drawing this by red color so that you may be able to recognize, right? So then let us draw it for 4. You can see this is 4. Distance of xy line from 4. Okay, let me draw it by blue color. So this distance, okay, so this distance, you measure it from here, and same like this is 4 and 4 coming from here. So you mark it like this. Let us say this is 1 1 and this is 4 1. Now this distance for 3, it will be equal to 1. It will be equal to 1. So same distance, let us say it comes out to be here. It is like this. So this is 3 1. We may not get. So anyways, then distance from XY line to 2. Let us draw it by green color. So from here, let us extend it like this. Let us say it comes out to be here. So this is 2 1. So now you join 1 with 4, 4 like this. So when you will draw it in actual, you will find out that here also, like you can see, this length or this dimension is smaller than this, because this will be larger, or this will be smaller. This is known as cutting plane. This is known as auxiliary plane. Okay, and this is the true shape of section. This is the true shape. So now, if you see this, when you are viewing it perpendicular to this, so this, actual shape you will get here. So auxiliary planes, like auxiliary planes in projections of points we had done. So auxiliary planes are of 3 types. First is auxiliary vertical plane. Second is auxiliary inclined plane. Third is profile plane. So what is auxiliary vertical plane? Auxiliary vertical plane is when your plane is perpendicular to HP and inclined to VP. Second, auxiliary inclined plane is when it is inclined to HP and perpendicular to VP. And profile plane is perpendicular to both HP and VP.
I hope the concept of sectioning is clear to you. We will be discussing more questions in the other videos. Thank you very much.